It's working. I can hear myself. So welcome everyone. Good to see you all here. And welcome to the OWASP London chapter. So for those of you who, here for the first time, you will see that we're actually live streaming. This is why it took me a while to set everything up. We're live streaming on YouTube, on the OWASP London YouTube channel. So tonight's meeting is hosted by this wonderful venue, by Civiltech Junction, and pizza and drinks sponsored kindly by Black Duck. I'm not sure if you had the chance to grab a pizza and beer already. They over there at the back. We also have a swag table. We actually have two swag tables. We have one with various OWASP swag and OWASP sponsor swag, and there's another table with Black Duck swag. So do make sure you grab some of these black rubber ducks, which is a kind of unique merchandise from Black Duck. Right, so for those of you who don't know me, my name is Stepanyan. I'm one of OWASP London chapter leaders. We have two other leaders. Andra, where are you? Can you stand up and wave? Yeah, she's at the back. So Andra and Sharif are also OWASP London chapter leaders. Sharif is currently unwell, so he cannot be here. Andra is around, so she will be sat at the back. If you're going to be taking pictures, tweeting, putting things on LinkedIn, please do mention OWASP London, because we're OWASP London on all social media. And if you are using Twitter or other social media which supports hashtags, please use hashtag OWASP London. Quick reminder of our code of conduct. We are a very friendly community, so we would like to stay very friendly and comfortable and welcoming community to everyone. So please be nice to everyone and respect everyone. Tonight's agenda is, after my short introduction about OWASP, and I'll update you about some news and updates about conferences that OWASP is going to have soon. We're going to have Balazs speaking about server-side cross-site scripting, followed by Q&A session. Then we're going to have a bit of a break where you can grab more pizza, beer, network with each other. And then we're going to have the second talk by Matthew, where we will learn about how challenging it is to secure software supply chain in our current age of AI, malware, and compliance regulations. And then we're going to have a raffle, kindly sponsored by Black Duck. And I will show you a QR code for those of you who have not registered yet for the raffle prize. Please do register. And then after the raffle, we will all go to the pub. The pub for tonight's party, our after party, is the Angel EC1, which is just around the corner. Please, by the show of hands, how many of you are here for the first time? Wow, that's like 30%. So thank you very much for finding us. I have no idea how you found us, but to make sure you don't miss the next event and you grab that ticket to come here, you can, first of all, visit our chapter webpage, right, and sign up to our mailing list. If you prefer to use the old-style mailing list, we have a mailing list where we only send notifications about our next event. We are on Twitter as OWASP London. We're on Facebook as OWASP London. We're Meetup as OWASP London, on LinkedIn, Eventbrite, on Blue Sky. Obviously, we are also on YouTube as well. We are live streaming this event right now on YouTube. And we also have OWASP Slack. If you're interested in joining OWASP Slack and join our Slack community, please do talk to me, and you'll need to give me your email address so I could invite you to join our Slack channel. Now, here's a quick show of the QR code for tonight's raffle. So those of you who have not yet registered, please do register, or if you wish to win this Apple AirPods 4. The QR codes are also placed on different tables where you have the pizza and the swag. And it will only be, obviously the raffle prize is only available to people who are actually here. Now, let me try and see if I can play our intro video and see if the sound will work, because usually it doesn't.
OWASP is a nonprofit that stands for the Open Web Application Security Project. OWASP is a community of developers, technologists, and evangelists improving the security of software through tools and resources. OWASP has 100+ active projects, and new project applications are submitted weekly. Projects are open source and are built by our community volunteers, people just like you. Community and networking. There are hundreds of local chapters worldwide and thousands of members. Meetings are free and open to everyone. They include training, talks, and networking opportunities. Education and training. OWASP hosts many events each year. They are a great way to improve your skills, build your professional network, and learn about new trends in the industry. One of the many ways you can get involved is to become a member. The membership benefits include discounts for events and trainings, your own OWASP email address and Google Workspace access, a vote in our OWASP Global Board elections. And recently, OWASP added a brand new member benefit, access to hands-on application security training through the OWASP Secure Flag Open Platform. Join us and become a member today.
Wonderful. Right. Let me see if I can move to the next slide, because this one always gets stuck and starts playing again. Right. Let me see if I can move. Yes. So just a quick slide about OWASP in the UK and Ireland. Obviously, we are all here in London, but OWASP exists worldwide, as you have heard from the video. And also in the UK, we have quite a lot of chapters, right? So we have quite a few new chapters like Peterborough and Reading, Bournemouth. If you are closer to this area, please do attend their meetups. If you live somewhere in the UK where there isn't an OWASP chapter and you traveled a long way to be here, and you are willing to volunteer and donate your time to organize and run similar meetups, please do come and talk to us, because we will help you to start a new chapter in your area. Now, quickly about membership, right? So OWASP membership comes with several benefits. So it's not just Secure Flag. We also have AppSec Phoenix platform available. We have security journey training. We have UBIC training. And we also have Checkmarks code bashing, which is the latest addition to our member benefits. And this is also an application security training platform, which is available to OWASP members for free. To become a member, it is $50 a year, so approximately 38 pounds, depending on the exchange rate, which has been changing recently. If you're a student, it's only $20 per year. If you're a corporate, if you represent a company, if you'd like to become a corporate supporter, we do have a corporate supporter program as well. So you can join as a corporate supporter, and you can have your logos displayed on the OWASP website and at our events. There are a lot of companies who are already OWASP sponsors, but we're quite lucky that our meetups are actually sponsored by a lot of companies as well. So these are all the companies specifically supporting OWASP London chapter. So a big thank you to them. So if you'd like to see your company logo here, please do talk to us. And there are some companies who also host our events. You can see a list of companies who hosted us. There are some interesting ones there. For example, John Lewis, AO, WorldPay, the Telegraph newspaper. We had JP Morgan hosting us. We had Amazon Office hosting us. We even had TikTok Office hosting us. And we're in Civo tonight. So can I please ask you to give a round of applause to Civo Tech Junction for hosting us? And another round of applause for Black Duck for sponsoring food and drink for tonight's meetup. Right, there's one thing that I do as well, just try to introduce the world of NFTs to everyone, because people say, oh, I need my certificate of attendance. I say, look, I've started doing this proof of attendance NFT. If you have no idea what it is, come and talk to me. Some people I know in the audience, there are a few people who are collecting this. So these are like Pokemon, so you're gonna catch them all. So at every OWASP meetup for the past 2 or 3 years now, I generate a sticker, this is a digital sticker using AI, obviously because it's quite hot outside. We have our cyber wasp with a fan, right? I have one of these fans in my backpack, by the way. So yeah, and you can come and scan the QR code from my phone, and that will be an ultimate proof that you were here tonight, because the only way to collect this NFT and transfer it to your digital wallet is by scanning the QR code from me right now here tonight, right? There's no other way of getting this NFT. Information about the conference. So OWASP Global AppSec USA is a big global conference which will be happening in November, first week of November. Call for papers. Actually, this is also just closed a week ago, but that's still there's still sponsorship opportunities available, or you can just attend as an attendee. We will be having more conferences next year as well. There will be an OWASP Global AppSec Europe in Vienna, and there will be OWASP Global AppSec in San Francisco next year. And also this year, I believe we have a Singapore conference, which will be in the middle of September. OWASP is well known not just by OWASP Top 10, by lots of other projects as well. So we have over 250 free and open source projects, and these projects are standards, tools, guidelines to help everyone to navigate their way into the journey of application security, which also includes AI nowadays, because AI is also software. So if you go to owas.org/projects, you will find all our projects. We have like 3 different levels of maturity for projects. We have flagship projects, lab projects, and incubator projects. And again, if any of you are actually creating any open source projects, I would encourage you to come and speak to us to actually bring your project to the OWASP umbrella, and then it will become an OWASP project, which means that you will get in a huge community of volunteers who will help you run and maintain your project, and you will have an opportunity to talk about it at various OWASP meetups and conferences worldwide. Now, one project that I need to highlight is OWASP Gen AI. So there's lots of cool stuff happening in AI world, and OWASP is at the forefront. Some of the OWASP AI guidelines and standards are now being introduced into the US government NIST standards, into EU standards as well. We have new guides for red teaming, for dealing with deepfakes. Obviously nowadays, AI is used a lot for deepfakes. A lot of people are using deepfakes for job interviews, for example, and I think there were about 25 cases of banks hiring North Korean spies who pretended to be software developers or IT people, use deepfakes and also used AI to create fake IDs to get them hired. Now, today, there's quite a few of you. I will try my best to run around with a microphone to collect questions. If you have any questions during the talk, you can use this service, which is called slido.OWASP, and you can ask your question online, and then I will pick it up and I will ask that question from our presenter. Now, the first speaker tonight is Balazs Bucsay. I hope I pronounced Hungarian name correctly. So Balazs is quite a famous person in offensive security, penetration testing. He's a speaker at many information security conferences. If you just go on YouTube and find his talks, he's been speaking for quite a long time, and he's been trying to come and speak here for a while, and it almost happened twice before, but for various reasons it didn't work, for whatever situations, whatever reasons. But tonight, finally, I'm very happy to introduce Balazs. One famous role that Balazs had was as a principal security consultant at NCC Group. Yeah, I don't know how many of you were lucky or perhaps unlucky to get a pen test report from NCC Group created by Balazs. I do have one, so there's a lot of very interesting findings. So tonight he's going to talk to us about an old vulnerability, but in a new light, so that'll be cross-site scripting on the server side. Let's all welcome Balazs. Great. So you can just share your screen, and I will give you the microphone in here.
Do I need to use both?
Okay.
Good.
I will take. Okay. Can use your computer. Move the. Okay.
It's fine. Cool. So thanks for coming. Thank you for the introduction, Sam. It was really nice. I really enjoyed it. I hope you enjoyed it too. So my name is Balazs Bucsay, but nobody can pronounce it. So just call me Buzz or Balazs or Bucsay. All works for me. So we will start a little bit of bio, but actually Sam told you half of it already. So I'm doing IT security for the past 2 decades. In the past 15 years, I worked in consultancy and research for multiple companies. You might know 1 or 2, NCC Group and Vodafone. I'm also a software reverse engineer, which I'm not going to talk about today, but that's one of the things that I do. I have a few certifications, but I'm not really into that kind of sports. And I love to do presentations all around the globe on different conferences, as Sam mentioned. I went to the US multiple times, including Hawaii. I've been all around Europe. This is my, I think, 8th or 9th event this year, which I really enjoy, and thanks for inviting me. And I've also been to the APAC region in Philippines, Singapore, and Australia. So I know very well that it might be hard to talk to speakers sometimes. So here are a few icebreaker topics that I really love to talk about. First one is IT security. Obviously, that's why we are here. The second one is sports, hiking, cycling, kayaking. I love to do those things. And I love to travel as well. I've been to more than 75 countries so far. And I have the soft goal to go around to every country if I can. You can find me on Twitter and LinkedIn as well. Same goes for my company. And yeah, last year I had a challenge. I was kayaking the Thames. I went to the source, and 9 to 10 days later, I finished at Greenwich. That's me in my kayak under the Tower Bridge, which gave me a really different perspective of the city, which I loved. I would love to go back and do it again. yeah, I think you've been there a couple of times. Yeah. So one slide about my company, which I founded 2 years ago. This is Monitoring Information Security. We mainly do traditional pen testing, web application, infrastructure, web APIs, mobile, and so on. Other than that, on top of that, we do specialized trainings like software reverse engineering that I mentioned already, and ransomware education for system administrators, ransomware detection for system administrators, and other than that, research, embedded devices, and software reverse engineering. Yeah, if you are interested about the services and you need more information, come to me. I'm really happy to talk about that. Also, there is the website that you can use. Please feel free to go on that. One more slide that I'm going to hijack here is about my book. I'm an author as well. I just wrote this book about scammers. The unique thing about this book is that it has 2 sides. So there are 11 stories, 11 chapters, and in each chapter you have 2 different interconnected stories. One is the victim side. We all know somebody, or we've been scammed already, so we know that side. But there is another side as well, which is the scammer side. And I try to connect the 2 sides together and explain to people how scams are done, right? So if people understand, if people are educated about scams, then we might be able to help them. That's my goal. That's why I released the book, and you can go on the website and download it for free. It's going to be on Amazon for a small charge as well. But the point is, it's not really for technical people. It's for everybody, for moms, for pops, grandmas, grandpas. If they understand what's written in the book and it's written in layman terms, so they should be able to do that. Then they might be able to realize that they are being scammed on the spot, which is a really good thing because they won't be scammed then. Yeah, so that was me and the company. We are going to talk about server-side cross-site scripting tonight. At least one of the topics is about that, which is a mouthful. It's even hard to pronounce. So let's unfold that a little bit. So first of all, I'm going to start with the cross-site scripting bit. Hands up if you know cross-site scripting already. I don't want to bore everybody, but I'm going to talk about a little bit. I think this is the most famous and most misunderstood payload when we are talking about cross-site scripting, which is alert 1. It's perfectly good for a proof of concept as a pen tester. We always put this into the report, but I'm really sure this doesn't talk to the report reader. So basically what we want to prove that we can execute JavaScript. With JavaScript, we can do a lot of things. Usually you see this in the report, but it doesn't really mean anything to you. So I fully understand that. There is a lot of meaning behind cross-site scripting. You can do a lot of stuff with it. Basically, this is an injection attack. You might know this. If you can inject HTML and JavaScript into a web page, and you can do JavaScript, and there are different kind of cross-site scripting, stored, reflected, DOM-based, and so on. But it's always in the user's browser where it executes, right? So even though people don't really care about it, there is a big impact behind that. The attackers can do a big impact. So let's see why we have cross-site scripting. Basically, there are different things. If you don't have any of these in your web application, you will have cross-site scripting for sure. So probably, well, if you have cross-site scripting, let's turn it around. If you have cross-site scripting, you have improper input validation, improper input sanitization, and improper output sanitization. At least if you implement one of these things properly, you won't have cross-site scripting. Anyways, the impact of this, and this is the most misunderstood part, it's not just an alert box that pops up in your window or whatever. You can do so many things with it, including user impersonation, account hijacking, website defacement, phishing. For example, if we are talking about ransomware or red teaming, what they do, they find a web page, they use cross-site scripting to deface the web page, and they send you a link to the defaced web page. And you will click on that link because it's a trusted website. It might be your company's website, your organization's website. You click on that, and there will be a login form, which is harvesting your credential. Since the website is trusted, you might provide your credentials on the website, and they can steal it from you. So it's really useful for red teamers. It's really useful for ransomware operators, and so on. So usually these bugs, not always, but usually these are really trivial to find. And because we don't really report it with the impact in our report as pen testers, it's really easy to misunderstand the impact of it and underestimate it. And as I told you, this is always in the user's browser, right? Yeah. So purposefully, I choose the topic, the title of this talk, as server-side cross-site scripting, because I don't want to talk about JavaScript injection or anything like that. But if we are talking about JavaScript, and we are going to talk about JavaScript, it's everywhere, right? It's in web applications, as we know. It's on the server side. If we are talking about Node.js, you can write web servers in JavaScript these days. There is the Electron. If we talk about Electron, that's you can create desktop applications which are going to run on the user's desktop. So the JavaScript is everywhere. And if we are talking about the impact, if we are talking about the vulnerabilities that are affecting these technologies and JavaScript itself, and we are talking about JavaScript injection, we can talk about cross-site scripting web applications. We can talk about remote command execution in web servers, Node.js, if you think about that, and also remote command execution on desktops in desktop applications that might happen in Electron. But I'm not going to cover these. I just wanted to highlight why I choose a different name for this presentation, because I'm going to talk about something different slightly. So I told you multiple times that cross-site scripting is affecting the user in the user's browser, right? But I'm going to talk, and that's running on the client side always. But is it always running on the client side? So that's the trick, right? So I'm going to talk about server-side cross-site scripting. That means that the cross-site scripting runs in the browser, or the browser is on the server, which is a really, I would say, unique case, but it's not even unique anymore because it's happening all around. So why would you run something in the browser on the server, right? That's a really good question, I would say. So you might have noticed that more and more web pages have this functionality where you can export stuff into PDF. You click a button and you get a PDF file. It can be your bank statement, it can be a website, it can be something from the website itself, just portion of it, or a report or anything. So you might have thought that how is this working on the server? So how is it being rendered? But there are the two, well, let's say two different approaches to this. One is the old school, where you have some kind of software library that can turn text, HTML, or docx into a PDF, which was developed over a long time, and it's a really complex thing to do. That might be the thing on the server side that is running, but there is a new thing, let's say, which is the new way, move fast and break things. That's kind of the approach that we kind of get used to it. And how they do these usually is a Docker container. In that Docker container, we have a Chrome browser, and that Chrome browser is opening an HTML JavaScript website, and that's going to be rendered, printed into a PDF file, right? So that's a kind of a new approach. It's a really lazy, well-working approach because we are using Chrome. We are using Chrome for browsing mostly anyways, so it's really good stuff. But if you think about it, there is Docker, which is kind of like secure by default, I would say. There is Chrome, which is quite a secure browser. You can get updates for it like every day or every week, it feels like it. They fix issues really quickly. There is HTML, which is a well-established standard as well, and you might be able to say that to PDF as well. So you have 4 different technologies, standards that you put together, so the outcome must be really secure as well, right? But that's not really the case. So the issue here, if you think about it, the Chrome is just like an operating system, or any kind of browser is just like an operating system. It's so complex, it has so many functionalities, so many features, it's unbelievable. Therefore, the attack surface is huge. So if I need to use an analogy, I would say that when you are using Chrome to render PDFs, it's just like using a nuclear plant to charge your phone, right? So it's a little bit overkill. You don't need it. You need a power bank to charge your phone or whatever, but you don't need a full plant, right? So that's what's happening there. And since it's happening there, there is quite a few things that can go wrong. So I set up a demo environment. When I do presentation, I like to do a demo so I can show the impact. I can help people to understand how these things work. So what I did, I created, let's say, a web application where you can go, you submit some data, and it's going to provide you a PDF file at the end. It's running in AWS. I'm using a Docker container, an ECS, ECR, Fargate, whatever that there is. And there is a little bit more to the environment that I will talk about in a little bit. So how do you turn HTML to PDF? I choose the normal way to do it. I Googled Docker, Chrome, container, whatever, and I found multiple solutions to this. But one of the best that fit my use case was the export HTML repository on GitHub. If you Google it, you will find it easily. So it provides an API over HTTP. You can post data into that API, and it's going to return a PDF file to you. So what could go wrong with it, right? That's a really interesting question, I would say. So I thought that I'm going to do this in clouds, in AWS, which was more or less a good solution for this. I thought it's going to be simple, but it seems that there is nothing simple in the cloud. So I use different IAM roles and roles and policies to configure this. VPCs, subnets, routing tables, internet gateways, Docker containers in ECS, ECR, Fargate, and also security groups. If you know how to do this, it can be done in a few hours. If you don't, probably a few days. So I deployed 2 different containers here. The export HTML that I already told you about. There you have the API that turns HTML into a PDF. And also I custom built a container because I wanted to add some flavor to the network to provide the demo for you guys. That custom container is intentionally vulnerable for a couple of things. Local file read. So basically you can send some user input into that Docker container and you can get local files from the container. So you can read files from the file system. And there is the SSRF server-side request forgery. You can interact with other servers, other services on the local network to that Docker container. This is a little bit of cheating here, I give you that. But whenever I do penetration testing for my clients or anybody, or I did it in the past, I always managed to find other issues on the network. So it wasn't just one issue, it was multiple issues, and you can chain those together, and you can do something really special. Cool. So let's see the demo, which is going to be a long one with multiple steps. There is this website. You won't be able to reach it, I hope. It should be limited to a few IPs. And this is the API, basically. I'm going to use burp. I'm not sure if you can see this. It doesn't really matter because it's going to be here for a really short time. But what's happening here that I'm going to post this payload here under that URL, under that endpoint. And whenever I do that, I get this back. You can see this is a PDF file from the header, from the magic values. And also there is a little bit of metadata in that file. You can see that it's running on Linux x86-64, so it's a 64-bit Linux. Other than that, it's a headless Chrome with that version, right? So it's using Chrome to render that PDF. I hope that makes sense. I created a few scripts to speed up the things. So I just need to specify the payload, and it's going to grab the PDF for us. But here's a set of payloads that I created. Can you see this in the back, please? Cool, 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 cool. So basically, this is the payload that I'm posting to the endpoint. As you can see, there is an HTML part to it, and it says hello there. And if we go into this one, list the files, we have a new PDF file saved to the disk. And that new PDF file is basically rendered. The HTML was rendered into PDF. Nothing special about that. There are quite a few payloads that we are going to go through. The second one is going to be an iframe. It's pointing to my website, to Monterey Information Security's website. If this renders, that means the Docker container has internet access, right? Otherwise, it wouldn't be able to get it. So let's go back to the console. On the second command, list the files, get the PDF, and you can see it worked. This is our logo, and actually there are a few stickers on that table. If you want to have a few really cool stickers, go there or just talk to me because I have quite a few spares. So next payload is going to be this one. But let's talk about this a little bit first. So we know how it works. I already told you that. And we want to figure out whether it's proper server-side cross-site scripting or not. We know that it can render HTML. We know it can access stuff from the internet, but we are not sure whether it's executing JavaScript at this point. It might be disabled. If it's disabled, you can't really do much. You can do some stuff. There is still impact, but it's not going to be proper cross-site scripting. So as you can see, this is the payload. It's going to write some tags into the document body, and it's going to do some subtraction. And if we get the number, which is the result of the subtraction, we know we can execute JavaScript. So let's execute the next payload, which is the second one. And if I open this PDF, it says elite. This is the number that we expected. It means that we can execute JavaScript as well. It's really great for us attackers. It's not really great for the client or for the victim, but this is what it is. So we know that there is cross-site scripting that we can abuse right now. It's running on the server side in the Docker container in a headless Chrome browser. We already have all this information from different sources and tests. So what can we do with this? Basically, there are quite a few things that we are going to go through. First one, we might be able to use SMB to relay hashes, steal hashes, and so on. SSRF, port scanning, access cloud data, cloud-related metadata, read local files, and do denial of service. So, I started with the alert one message box, the most basic payload. This is what we usually put into the reports because we think that the client people will understand that, but that's not the case. This is what we should do instead to explain the impact of the vulnerability. So first of all, if you are running this Docker container or something like this on a Windows machine, on a Windows server, you will be able to open SMB shares. If you are able to open external SMB shares, then you will be able to steal the hashes, maybe crack the hashes and log into the organization's network or in that server, if that server is domain joined. Or you can relay the credentials to an SMB service on that network. So that's something that is a huge impact. It would be a high or critical usually. But since we are running the whole Docker container on Linux, this is not going to be an option for us. There is another thing that is not going to be an option for us, unfortunately. I'm going to show you why, but this is the local file read. So from Chrome, you can open local files, right? You just type the path to the file and that will open it. You might be able to do that from HTML and JavaScript as well, but only if the same origin policy matches what it needs to match. So from a website, you won't be able to open local files. From a local file, you will be able to open local files. It might be a bit confusing here, but my point is that we need to figure out how the payload is rendered. If it's written into a file and the headless Chrome is opening that file, then we will be able to read local files. If the rendering goes to a web page or something different, we won't be able to do that. The way to figure that out is that we need to figure out the value of the window location, right? So let's go back and do the next payload, which is payload 3. This is the payload 3. We are going to print the window location. And this is about blank. So what you need to know about blank, it's not considered as a local file. So we are not going to be able to do local file read, unfortunately, this time. No, you can't really write from browser, at least not from HTML and JavaScript. Yeah, the next one is denial of service. So you can always kind of do that. I choose not to because there is no point for me. What you can do infinite loops from JavaScript. You can do recursive loops, recursive function calling from JavaScript. You can load up a huge HTML file with a lot of pictures, which will take a lot of memory and time to render. And if you do that multiple times, you might be able to block the server or the Docker container from operating because it will take a lot of time, memory, and CPU resources, and all kind of resources. So I don't usually do that, or at all, to be fair. So let's not talk about that more. The next one is cloud metadata. If the solution runs in the cloud, AWS, GCP, Azure, you might be able to do something with the metadata. If you don't know metadata, it's always under that host. It seems to be unified, universal between the cloud providers. And if you go on that web page, then you can get a lot of information about your instance that is running. So in this case, it's going to be the Docker instance, right? If we are talking about EC2, which is the computing engine, computing service in AWS, you might be able to get a lot more, for example, credentials, session tokens to the cloud, or private keys to log into other servers. So there's a huge impact if the owner stores stuff into that. So there are different ways to access this. In AWS, Amazon, there are 2 different ways. There is the old obsolete one, which is the AMD S version 1, which is a simple request response solution. Just going on the website, you include the website, you get the response back. they realized quickly, not so quickly, but they realized after the years that this is a huge issue. So they introduced another version of this, which is the version 2, where you have a session-based solution. You set a you send a put request with an extra header to this service. You will get back a session ID, and you need to add that session ID into the follow-up requests that are GET requests. The issue for attackers and pen testers is that you can't really add. You can add headers to your requests, but you won't be able to get, in this case, back the response. So you won't be able to get the session. And since you are not able to get the session, you won't be able to do the follow-up requests. So this is not going to work for us. And also, I told you that I used ECS for the whole thing, not EC2. So this is not relevant anyways. But if the rendering runs on a virtual machine instead of a Docker container, then you might be able to do something like this. For GCP and Azure, you can get this similar metadata from the same IP, same host, but the way how you access it, you just need to add an extra header. For GCP, it's metadata flavor. For Azure, it's just metadata, right? But since there is course, and you won't be able to get the response, it's not going to work for us. I just yeah, let me do the demo for this as well. So payload 4, we are going to use an iframe with the host that I just told you. So if there is some metadata, that should be there. And as you can see, there is the iframe. You can see it from the borders of this box. And you might know very well this little icon. It didn't render. So that IP, that host is not available for us. Let's see the next one. Yeah, before we do that, one little thing. So I told you it's not EC2, it's ECS Docker containers that are used in the cloud. And for some strange way, I don't understand. Probably to be fair, I didn't even look into this, but it's really strange to me. For ECS, for Docker, there is a completely different metadata host, right? It's a different IP, different way to access it. It's not session-based, it's a request-response-based stuff. But there is a trick. You need to know the GUID, which is a global unique identifier. How do you get the global unique identifier? You can find it under this file. So if you manage to read that file, which we weren't able to do, you might be able to get the GUID. If you get the GUID, you get the metadata. And that metadata is really juicy. It has different session tokens that you can use to access data in the cloud. So this is the host that I'm going to put in an iframe, which is the ECS one. So that's payload 5. Let's run payload 5. Sorry, it takes some time. Oh, there you go. So that metadata rendered, right? So you can access this metadata. And although there is nothing juicy, nothing really, really useful, or not, there is a lot of useful stuff in here, actually. Nothing really sensitive in here. So what you can see here, for example, Docker name, that's the name of the Docker image or the Docker container, not the container, the instance. The image is bedrock.io export HTML, right? So that's a really good thing. So if you do vulnerability research, you might be able to get that image from GitHub. That's what I did. And you start to do vulnerability research on it, and you might understand how it works, and you can exploit more vulnerabilities. Other than that, there is a cluster name, and so on. And what's really important here, there is an internal IPv4 address that we might be able to use in the next few steps to attack internal network services. So just remember that address. We kind of going to use that. You can get more data out of the metadata service. This is about the CPU and disk and memory usage, but it's really not useful for attackers. I just wanted to show you that it's kind of a gold mine for attackers. Cool. The next thing that we can do, and these are going to be chained together, so just bear with me, right? The next thing that we are going to do is port scanning. That's what you can do, port scanning from HTML and JavaScript, which might be something new to you. So there is this guy, Nikolai. He wrote this article, which I enjoyed really much so. I really recommend it. You should read it if you are interested in this kind of stuff. He's using WebSockets and image tags to do port scanning from the browser. This kind of port scanning that he did still kind of works. It's not fully reliable, but it's better than nothing. The browsers implemented some mitigation, but it's not fully working neither. But there are also old school ways to do kind of port scanning. So you can use the timeouts. If your PDF doesn't load for a long time, that means that the headless Chrome can't access that service that you wanted to render, right? So there is going to be a timeout, maybe for 15 seconds or something like that. Usually, if the response comes back in a few seconds and you need to wait 15 seconds, you know that there is no service. And also, you can use iframes to load up data for HTTP and HTTPS services. So next thing that we are going to do is payload 7. This is a compressed payload for some reason, but this is the code itself. I'm not going to read it to you. I'm not going to explain it to you. It's in the article, but it's used for port scanning, right? What you need to do, you need to specify the IP and the port, and we are going to scan that. So you might have noticed that this IP is an internal IP. It's under the same range I already showed you from the metadata. So that was a hint. And I'm going to use the same network to do the scanning. I'm cheating here. I already scanned the network to save time. This is an alive IP, and I found an open port on it as well. So that's the other service I told you about. So that's 7. Payload 7 running was returned. So let's open payload 7. Oh, it says false. I told you it's unreliable. Huh. Yeah, it says true now. 1 out of 3. Anyways, trust me, you can use this, even though it was unreliable now. It says it's open. Yeah, so the next thing that we do is payload 8. So we are going to use an iframe to load off that web page, right? So this is the same IP, same port that we scanned, and we found to be open. 8. So this is the web page. It's in an iframe. It's kind of like capture the flag right now. I'm giving you all the hints already, just to speed up the process and just to make it more digestible. The website tells us to try this endpoint, LFR, local file read, with the file name, right? So the next payload that I would use for an engagement is basically this payload. I would load up the etc password file with this local file read vulnerability. Obviously, it takes a lot more trials to figure this out, but this has happened to me multiple times on a client engagement. So this is payload 9. I already executed it for you, and as you can see, this is the password file content. You see, you can do local file read through this vulnerability that I intentionally put into that Docker container. Cool. So what's the next step? Any guesses? Which file do we want to read? Come again? Shadow. Yeah, that will be a nice one, but we might not have the credentials for that, permissions for that. We might not be root, but why not? So let's do shadow. That's payload 9. . Well, actually, that worked. So we know that the container is running as root, which is a vulnerability in itself. We can read the shadow file, even though there are no passwords in that. So that was a good shout. Thank you. But I was thinking about something else. So if we go back a little bit, I told you about this file, right? You can get the GUID from that file. So let's go for that. There's the next payload, payload 10. We are doing that file instead of the shadow file or password file. So let's execute that. And this we execute it. And check the payload, payload 10. You can see it's kind of like the metadata again. A lot of white and black text. And here, you have something similar that I already talked about. So if you copy this value, which looks like a UUID, and you put into the next payload here, format it. That's really important. I think that's it. Then we are going to open up this URL, which is payload 11, the last payload. Just bear with me. Cool. So that's a lot of stuff, right? Here you have the access key ID, the secret access key, the token as well, and then you can use all this to access some stuff in the cloud. Don't take a picture of that. Sorry. It's in a test environment, so you can't really do harm. But still. So I'm going to be lazy, and I'm going to just go back in history. I did the testing today already. I'm going to export these values on my local computers. And use this command. So this is the command line interface for Amazon, AWS. You can do basically almost everything through that command as you can do over the website. It's just easier if you are a developer or an engineer. And with this command, I can see that I can use that session, the token, to do stuff in the cloud. I managed to authenticate against the cloud. So the next step that I would do, if it was an engagement, is use a tool to figure out what kind of privileges or what kind of access I have in the cloud. This is my cheat sheet, just the speed of things. And this is a really handy tool, open source. You can get it from GitHub. If you provide those if you provide the access key, secret key, and token to this tool, which is valid, and we checked if it's valid, then it can kind of brute force what kind of stuff you can do in the Amazon environment. And as you can see, we can list buckets, S3 buckets. We can do DynamoDB stuff. And I'm going to stop this, but otherwise we will be able to do a lot more than that. So again, going back to my cheat sheets, we know that I can access S3 buckets, which is basically storage in the cloud. I just listed the storage in the storages in the cloud, and there is only one that I can access. Which is only for admins. It already talks to us. If I do this, there is this, in that storage account, there is this file, secret.txt, and I'm really curious what that is. The file size is 66 bytes. And I'm going to copy that file into my computer from the cloud. It's done. And if I check the content of it, then you can see, I hope you like the presentation, AWS owned via server-side cross-site scripting. So this is the impact, basically. Cool. So going back to the repository on GitHub for the Docker container, HTML-export, you can find it yourself. It's the same as it was a year ago when I put this presentation together. The repository says one thing. There is a security note, which is really cute, also valid. I fully support it. Let me read it to you. This is intended to run as a microservice. Do not directly expose it to the public internet. And I fully stand behind that. But the issue is that, as you can see, there is a lot more to it. So just because you shouldn't expose it to the internet, there are quite a few hardening steps that you should take. For example, if you decide to use this kind of solution, maybe you can disable JavaScript, you run it in a fully isolated environment, and validate your input, as I mentioned. So I tried to do the right thing, as I always try to do. I went on GitHub, opened an issue a year ago, and I told the guy, the owner, that maybe you should do a bit more hardening and also change the README, because it's not going to serve people very well. They just download it, they just use it, they implement it in production, and it's going to cause a lot of vulnerabilities. And as you would expect, the impact of this security vulnerability, impact of this issue was huge. It even got 2 likes. That was all. And I'm not going to lie, one of the likes was me. So, you know, that's security, isn't it? Cool. So let me talk about a little bit about the fixes and mitigation. First of all, if you want to do PDF render, first of all, let's start with cross-site scripting. If you don't want cross-site scripting in your web application, you need to do at least one thing out of 3 things, right? You need to implement either of these: input validation, output validation, input validation, input sanitization, and output sanitization. If you implement one of these 3, at least one, then you won't have cross-site scripting. There is a really cool web page called OWASP. You can go on it, and you can get the cheat sheets, which tells you all about cross-site scripting, how to fix it, what the issue is, what the issue it is. So you can learn a lot from it, or you can just contact me, and I'm really happy to help. If you decide to use any kind of technology, but for example, this rendering stuff that I just showed you, you might want to take a few steps. Even if you are not a security professional, you are able to do these kind of things. First of all, is threat modeling. So whenever you introduce something new to your network, to your environment, just sit down, think it through. What kind of stuff is going to be able to access? What kind of impacts is going to have on the network? What is the harm that I could do with it, right? So if you think about these things, you might have a kind of a map, a list of things that you want to implement before you implement this whole thing, because you want to put those fixes, mitigations in place before you do anything. If you think you are not capable to do this, which is fine, just go to your go-to professional, maybe the security guys in your company. They will be able to help you. There is the least privilege principle and separation of duties, which I always mention. These are really, really important. You shouldn't provide more privileges to the Docker container or anything on your network that is absolutely necessary, right? You should set up a different role with limited permissions that are assigned to that Docker container. And when you do that, you are going to be safe, because it won't be able to do anything. In this case, it was able to access S3 buckets for no reason. Therefore, you can limit that, and it won't be able to do any harm. And defense and depth, that's the last thing that I wanted to tell you about this bit. If you put any Docker container or anything on your network, you might want to segregate that put into a network where it can't access anything, definitely can't access the internet, and you want to use strict firewall rules to control the access. For this Docker container itself, if you really want to use this, I'm not going to stop you, but you might want to consider disabling JavaScript, configure the headless Chrome browser as secure as possible, as limited as possible. Just think about the nuclear plant versus power bank analogy. You don't really need a Chrome browser to do this, and it's really hard to configure it securely as well. But if you really want to do it, try your best and run it in a fully isolated environment. So that was it. If you have any questions, I'm really happy to answer. Thank you very much. Thank you. There was one question, sorry, Sam, if we could start with that. Cool.
So there's not scenario HTML. If we are using those services in disposable browsers, is it still NSP?
Sorry, what browser?
Disposable browsers. There are a lot of products out there, which are like not VPN, but are proper disposable browsers. You just open a file for it, or want to use some files. You just open it in disposable browser. It will not affect your environment or PC.
It's hard to answer that question because I'm not sure where the disposable browser is running, right? If it's on server side and it can access other stuff, it might be an issue. If it's a limited environment, as I recommended, like a segregated network, it might not be an issue.
Probably running a Docker container. Thank you. Questions from the audience? Yeah.
So the usual protection of cross-security content security policy, but they might implement the browser level as the Chrome headless should add something as a protection.
Yeah, definitely. So the headless Chrome is the same stuff as Chrome. It just doesn't have a GUI, right? So you don't have a screen or anything. Otherwise, it's fully the same stuff. And you mentioned that content security policy is the mitigation against, I'm not sure how you phrase it, but it's a mitigation against cross-site scripting. It's not going to stop you have cross-site scripting. It might stop some of the cross-site scripting. So you shouldn't rely on CSP purely. You should fix your cross-site scripting and have CSP as well. I hope that answers your question. Thank you.
Any more questions from the audience? No? Okay, there were 2 questions online, Balazs. There's one question about payload 11, and the question was, would it be possible to run a reverse shell at that stage?
Payload 11, I think that was the one where we got the... Yeah, so this is just local file read. So it's just reading files from the local file system. Whatever you have on the local file system, you might be able to read depending on your permission or your privileges. As we could see, we had root privileges because we could read the shadow file, but this is only reading. So we are not able to execute anything. It's just for file read.
One question, and that question was, there is a GitHub repo which allows you to embed a Doom kit inside the PDF. Someone's asking, would it play Doom?
I've seen that, and yes, not on the server side. Basically, I haven't checked. Yeah, that's a really good research stuff. Yeah, I will try. I will try.
If you miss font size is quite small, all the talks are recorded, and you'll find the recording on OWASP channel. So let's do a huge round of applause.
Thank you.
Is of its drinks right for this line. Yeah, I'll see you later again.
So if you kind of search on, it's primarily available
Come again?
Chrome. So it's an extension. If you search, there is a company called SquareX, who are SquareX.
Okay, so let me stop this here. Maybe I can use this one. Like this. Is it the one that you talked about?
They do have a browser or even an extension which allows us to, so if I want to open any file which I feel I'm not sure about, is it malicious or is it containing anything, so I can just open those file into their extension browser. So my particular device got to be affected.
Yeah. I heard solutions about like this. It depends on how it works, where it's run, because there is a browser, right? And probably that's configured securely, but needs to be checked. I think you are going to be fine. Usually these run in their cloud, not your cloud or not your environment. So, yeah, I think so. It's not going to affect you. It might affect them. That would be my answer to it. Thank you so much. Thanks for coming. Oh, sure. Thank you.
I will go to this.
If you don't have a wallet, you just put your email address. Give me a second because this is closed. If you have a crypto wallet, just copy paste your address. If you don't, just have any wallets. You do email address, and then I'll tell you how to get the wallet.
Right. But again, please just give us some of your email address and that, so you reserve it, and then you can receive it. Stick around for the next stop. Ian, good to see you, mate. I think we need to talk through the. I'll introduce it. Right. Secure core. I will send you an invite to join our Yeah, they all right. From AI to Java security, so let me take this aside.
Let me take the glasses off for a moment.
Sorry, the mic is pointing upwards. Should be fine. Yeah. Okay. Great.
Perfect. Thank you. Yeah, I'm going to put that on the other side. Yeah. Thank you.
I think this mic is a bit better.
And this one.
Both mics.
Oh, I see.
The audience, this.
Oh, I see. Okay.
My memory.
Right. Sit down, people. Sit down, people. Oh, you're too much sitting. This way. Huh? Yeah, fine. I mean, this is a very technical audience, so I did understand it. Yeah. I'm not sure what the purpose of it was. It was interesting, but you know, it's an exercise in hacking, I suppose.
Yeah.
I don't know why one would do that. I need to get the Zoom as well.
Okay. Otherwise, it's better if I plug in the training to the Zoom because then it will go.
Oh, okay. Got it. Sorry, I messed that up. Yeah. I need to use both. Shall I start sharing? Yeah. People enjoying the pizza too much, aren't they? Oh dear. They got your name wrong as well, did they? Ah, I'm speaking and I wasn't on the list. So you see, it's not a sign of anything really. Oh, perhaps that's been swapped. Who knows?
We are ready for our second speaker. Matthew from Black Duck has a wide range of expertise in lots of DevOps and software development lifecycle solutions services across different companies, organizations. So currently, he's a subject matter expert in software supply chain at Black Duck. But in previous life, Matthew worked for Cisco, AppDynamics, and HP Enterprise. That's all.
So, hello, can everyone hear me? Is this on? Yes, is that good? Put it on. Okay, there we go. That one there. Yeah. Is that better? Yes, there we go. You can hear me. So, thank you, Balazs, for a very interesting session on actually hacking into things. Mine won't be quite so educational, but I hope it'll be interesting, is the first thing. And I thought I would start, not with me, because you've heard about me, but a little bit of history. So, my slides will go forward. There we go. Okay, so I work for a company called Black Duck, and you may have heard of that name before, but it's a reincarnation, okay? Because Black Duck was around a long time ago, and then was acquired by another company, which is our former parent company called Synopsys, and we were spun out last year, so we had to come up with a name, okay? But we looked at all of the things that we've been doing for 20 years plus, and we decided on Black Duck, okay? And it's useful just to go back to talk a little bit about that history. So one of the first companies, or rather the oldest companies that we acquired in 2015 was Digital, and they created the first SaaS tool, which was called ITS4, which I love the name of this. It's called It's the Software Stupid Security Scanner, okay, which I think is a brilliant name. And then those people went off and formed Fortify to create Fortify in the mid-2000s. And then other companies and acquisitions, including White Hat and Codenomicon. You might know Codenomicon. They were the research team that found Heartbleed. Okay, so you might have heard of that. So they were involved in that, again, out of Oulu University in Finland. And that's a fuzzing tool that they produced. And of course, Coverity, I don't know if you've heard of that, the first commercial SaaS tool in 2002, out of Stanford University, Black Duck, which was formed in 2003 and was the first open source compliance tool, initially focused on license compliance, but obviously a lot more than that now. And then some other stuff there as well, and all the way through to our latest platform. But you know, it's interesting. There's a lot of history there, and I think it's nice to reflect on the history in this room as well. So as I look around, I would love to know some of the stories of things that people are working on or have worked on. And I will just go a little personal for a moment. So I started back in the 80s in software, working on AMDAL plug-compatible IBM mainframes, Unix timeshare. Okay, so it was an IBM running Unix. And then moved through to various things. And one of the reasons that I've ended up in this space is because I work for a company called McCabe and Associates. So does anybody remember McCabe cyclomatic complexity? Has anybody heard of that? Cyclomatic testing, which was the big thing in the late 90s about testing software to do with combinations, linearly independent paths. And so things like, we used to look at software and wonder why it was very slow and difficult to test, and find out that it was, you know, 500 statements in sequence, which gives you more paths than there are atoms in the universe. So sort of gives you the problem of why, you know, these things are really difficult, why we will never get to the bottom of what software and computers are actually doing. And we'll come to something else there anyway, but do come and talk to me afterwards. I'd love to hear your stories, because I don't know, I just really find it very interesting. Okay, so that's the history. One thing that you may not know is that Coverity has been around for a long time, and it has a free open source version. So if you're doing open source and you want to test your code, then you can go to scan.coverity.com and scan your code using Coverity Static Analyzer. Of course, you might know this project. It's been scanned for nearly 20 years now. And Coverity is responsible for 50,000 vulnerabilities in the Linux kernel, which have been fixed using, identified and fixed using Coverity. So just as an example of the history there, and of course that's always like a freebie. There are more freebies over there, although I see a lot of them have gone, but, you know, so, and the pizza as well. All right, so that's a nice background. There's a lot going on at the moment. Our research shows us that in 2025, we expect there to be 100% more code by the end of the year than there was a year ago. I mean 200% more, if you see what I mean. So AI is going to drive 100% increase in code this year, and possibly 400% or more by 2030. So a great deal of code is coming our way. And in fact, it leads to a lot of problems. Things like LLMs doing you know, what they're doing, but then the citizen developer is an interesting thought. These are people who probably at some point in the near future will be writing applications without understanding any code at all. And then of course it's our job to try to work out what the hell's going on and what it does and what the AI wrote. And there are actually more scary scenarios. We'll come to that in a minute. And then of course the other thing is that the regulators are sort of getting going, and we've got lots of regulation coming in different sectors, which is confusing, overlapping, difficult to understand. Takes a full-time job just to understand what they're trying to do and what you have to do. Okay, so we'll talk about that in a moment. So let's talk about the software supply chain, and let's just talk about the challenges of it. So it's a big topic, and I've got a lot of slides. We can stop early, you know what I mean? I really could go until midnight, but I will stop on time, I promise you. So let's see where we go. So that's the starting point, is regulation, okay? So what we see here is huge amounts of new regulation coming in, especially from the EU, okay? So things like the Cyber Resilience Act coming in by May 2026, things like the NIS2, which you probably know about, DORA, and another one that I found the other day, the Product Liability Directive, which essentially says if vulnerabilities and issues are found in software, or applications which use software, or hardware that uses software, then individual consumers and corporations can actually sue for liability. So there's a real issue there around, you know, what are we delivering, and when we deliver it with vulnerabilities, and those vulnerabilities do things, what is actually going to happen there? Now, from a supply chain perspective, what do we actually need to do? So there's lots of things that we need to do. That's the whole list there. The things that I'm particularly interested in, because I'm a supply chain expert, are the things which are marked in red, okay? But clearly we, as an industry, have to do all of them if we're in different areas. And clearly it does depend who you are. That's everything that's delivered as a software or a service or an application or hardware in the EU will be required to cover the CRA. We don't actually know what that is yet. I mean, there's a huge amount of talk about it. The ENISA organization, as you probably know, hasn't yet set the technical definitions of that. I spoke to someone from a company who's involved in one of the 17 working parties to do that, and that was on May the 7th, and he'd just had their first meeting. Okay, so that's how far behind the technologists are working out what the hell the regulators meant when they did the CRA, do you understand? So there are things like the potential for S-bombs, but we don't actually know what that means, because the actual text of the CRA says S-bombs for direct dependencies only. Okay, so what does that mean? What's the point of that? It's like, excuse me, why? It's like saying, you know, I want something, but I want to break it. It doesn't make any sense, okay? And also, who's going to see those S-bombs? What's the requirements for reporting vulnerabilities in what time scale? What type of vulnerabilities? Is it internal? Is it external? What about public? What about private? What about code? What about... There's so many things we don't know. So let's be honest, there is a lot that's going to happen in the next year or so on that, and many other things. So a lot going on that area, and also a lot going on in this, okay? AI, software development, agentic AI, creating software, writing software. What's it doing? Is it good? Is it getting better? Is it getting worse? Can we trust it? All sorts of questions there. And clearly the sorts of things we're worried about are things like it clearly is been trained on open source. That's what it's been trained on at large scale. And it uses, because of random selection, it can sometimes use the strangest dependencies that you've ever seen. You know, like suddenly switches because it's trying to, quote, look like it's intelligent because they're slightly manipulating the weightings, suddenly switches to something. You're like, why did you choose that? Obviously, there's a far better one over here that you could have chosen. So there's a real concern about this idea that they're trying to make it look intelligent, but they're actually just making it randomly choose between rarefied and unusual open source. It's an issue, okay? And there's lots of things there, and we can talk about some of those more, but I didn't have a very good night's sleep last night, okay? It wasn't intentional, I just happened to start watching YouTube late at night. And for some reason, I managed to come across this video called AI 2027. Has anybody seen this? One person, okay. And perhaps I could speak to you afterwards because I do need to talk to someone about it, okay? Because this is probably the most scary thing I think I've seen in several years, okay? This essentially is 20 experts who did an assessment of the path to AI, in fact, AGI, general intelligence, artificial general intelligence, and that their worst case scenario was that by July 2027, we will have lost control of the AI. It will be doing things. It will be writing the next generation of code. It will be designing the chips of the next generation of code. And it will be writing that next generation of code without explanation in essentially internal machine code. It won't explain what it's doing. It will look like it's doing what we want it to do, but we have no idea what its actually motivations are, okay? And I just really need to point that out. Now, there was an alternative. They did two extremes. One extreme was that, the fact that by 2027 we might lose control. The other one was where we actually press the stop button for a moment, okay, where somebody says, and by the way, the whole thing about the 10 people on the committee, you know, it's called the, I forget the word, you know, the people who look after the AI. There's 10 people who are on the, yeah, the words escape me for a moment. But these 10 people, you know, and if they just vote 6-4 to slow it down, then they might say, no, we're not going to use Gen 5, 6, 7, because it's been written by the AI and we don't know what it does and we can't see what it does and we know it's going to lie to us. And they say, no, we'll go back to the one that we can see and we'll instruct it to write a safe AI, and that will take away a year and we'll lose the race with the Chinese, but that's worth it. Okay, so just to say, I need someone to talk to me about it if anyone's seen it, or perhaps we could take my email address and tell me what you think afterwards. It did not seem to be too much hype. And the other concerning thing I saw was that out of 30 specialists they spoke to at the end of this, they actually said that, well, virtually none of them disagreed about the end point. They just disagreed about the timescale. So some food for thought there, okay? And I just want to point out that the rush towards AI to secure applications, to test applications written by AI, seems like a bad idea to me, okay? I think that we should treat AI like a bad actor when it's generating code, and we should put it through the most rigorous testing of every type that we can think of because of the code that it's writing, okay? So that's my perspective. I may be somewhat jaundiced, especially after my experiences of yesterday. All right, so anyway, there are some things we do know. AI, when it's writing code, is more prevalent to do certain things and less prevalent to do other things. So it's like a sort of optimized developer in some ways, but it tends at the moment to be quite scoped to function, you know, to local function, not to application hierarchy or architecture. So it typically is doing less of those sorts of things and more of those sorts of things according to our research, okay? But essentially it's still being a developer and it's still making mistakes because it doesn't understand the whole context. So these are the sorts of things that we need to look for, and that's the sort of thing that Coverity Static Analyzer can do for you, okay, is to find those sorts of issues from the AI-generated code. Another point around generated code is IP risk. It's been trained on every piece of open source in the entire history, whether the people wanted to train it or not. And there's this issue of what happens when you insert code from, which is a direct copy and paste of a GPL restricted piece of code. Is that a good, you know, is that acceptable? The answer is no, it's clearly not, okay? So there is this issue of copying code. And then, of course, we have the problem of what is the actual license of a piece of software, okay? Here is an example, just an example from GitHub of a piece of code. I can't remember what I chose. It's called it's called, yeah, some form of rational fraction function. And it says that it's MIT. You can see on there, it says MIT. But when you go and look at the source code, it's MIT or GPL. Okay, and that's there for a reason. Okay, and you can't just say, oh, I'll choose the non-or case. That's not legally binding. Okay, so this problem of people relicensing code just by copying it into GitHub and saying it's MIT, and then every tool on earth just saying it's MIT, this is not acceptable. Okay, from an IP risk. So there's this issue of copy and paste, the deep license issue. Okay. Now, if we look at that AI Act, one of the things, I don't think it was on that first list, something else that's on there is the AI Act. Anybody who is delivering applications which use AI will be legally required, I can't remember the dates, again, it's a year or two, legally required to actually catalog what they're doing, and then some things are forbidden, some things are restricted, and some things are less restricted. And you have to do things like tell people that the results are from AI, tell them, notify them, and so on. And you can't, there are certain things you can't do around pretending to be a human, okay? And one of the things that you need to do as a developer of an AI solution is determine what model you're using and where you got it from. And obviously you then have to start creating something called an AI bomb, okay? The bill of materials for the AI that you're using and all the code around it. So SBOM and AI bomb sort of combined there. And the reason is because if you are just taking a public model and you're then modifying it a little bit, then you are considered to be a deployer. But if you take the model and rebuild it from scratch and change the layer 0, you become a producer and your requirements are different. Okay, so issues around determining, tracking the LLM usage. Okay, so a lot of things, and particularly scary one around the AI video there, but let's move on from that. So anyway, what exactly are we talking about when we talk about the software supply chain? So the answer is we're mainly talking about open source. So our research, which we've done for the last 15 years, I think, is that last year, 70% of all code that was produced was open source and 30% was custom code. Okay, so that's the sort of normal, that's been normal for a long time, varies a bit by language, but it's pretty normalized. Something that has happened is the sort of proliferation of components per code base. So what we see is 911 components per code base. That's nearly double what it was before, mainly because of JavaScript, because it's a bit of a mess because of what it does. So the prevalence of JavaScript has pushed that number up a lot, but it's a lot. It's a lot of dependencies in your project, okay? And then 81% of the code that we looked at had critical or high vulnerabilities which had not been remediated, which means it's just not working. For production code to be released and have 81% higher critical vulnerabilities, which should be, that's a problem, and 59 average vulnerabilities per code base. Again, sort of, it's not working. We're clearly not getting a grip of this. So let's just spend a few moments on JavaScript. By the way, we had a great session from Balazs about JavaScript and cross-site scripting and so on. Very powerful. But I'm going to ask you to, I'm sure most of you do development anyway, but if you don't, I'm going to ask a thought experiment, okay? And the thought experiment is we're going to build a tool to integrate Slack and Instagram. I have no idea why. I mean, I don't really know, but we're going to do it. And we're going to use JavaScript. Of course, we're going to define some dependencies. There's my top 7 dependencies, mainly stuff like the Slack Bolt API, the Instagram API, and a few other things, okay? Pretty normal, 8 dependencies. Problem is, this is where it goes a bit haywire, is each one of those has many dependencies, okay? And clearly it starts going a little off the scale, I think it's fair to say, because that is the tree for one of those 8 dependencies, okay? That's the tree for one of them. And I couldn't get it all on, so I put it on the big diagram on the right, and I matched it in there so you can see that I'm not lying, it's true. Okay, that's a bit of a problem, because what happens if there's a vulnerability reported against that? What do I do about it? Anyone? patch it. How do I patch it? How do I patch that? I don't. I can't. Sorry? I didn't hear that, sorry.
Leave it there.
Leave it there, yes, exactly. The only thing I can do is wait for my direct dependency to be upgraded once this has been fixed, or mitigate the vulnerability by some mitigation alternative control, which of course is the common thing that we have to do. But it's a problem, isn't it? You see the problem here? It's really very difficult to do. This idea of constantly upgrading all the time. And another point. I developed some open source, mainly for Black Duck software, but I do it in my spare time, okay? And I made a mistake this morning where I literally merged the wrong thing into the main branch, okay? And I'm not the best GitHub person, and I didn't know what I was doing. And I ended up upgrading the core component that I know a lot of people are using. I'm like, oh my God, how do I undo that? What do I do? What do I undo it? I'm not a developer, by the way. I do it as a sideline. And that's the point, is that's what open source is. It's people like me and you in your spare time doing it as a benefit to humanity. And then commercial companies like us, but also all the ones you work for, or not as the case may be, are using it to make money, okay? But they just don't realize that it's fragile, okay? And we have this problem. So there's some real issues there, okay? Now, here's the other elephant in the room. Most of what I've talked about there is dependencies, okay? So that is a way of including stuff in my code, okay? Via a package manager, JavaScript, NPM, Nugget, Maven. But it's also possible to install things intentionally or unintentionally alongside that, outside the package manager, okay? So things which are not in the package manager. Of course, the original method of managing open source was to copy the repo into my project and compile it as if it was my own. And that is still available because it's required. I mean, open source, it's in the name. I can take any component, copy it in, modify it, delete it, do whatever I like with it, and compile it as if it is my own, okay? That is not a package definition, that is an inclusion. Of course, another thing that happens a lot is copy-paste, especially when we talk about generative AI. So in the scope of generative AI, putting code into our applications, what we actually have is snippets of code being inserted, okay, small blocks into functions or classes or whatever it may be. And of course, another way of including third-party code is the binary method, the DLL, the exe, the lib, the archive of some type, I don't know, machine code something that I pop in, .so. So lots of binaries there. And of course, containers, brilliant. They're wonderful things. They really make the world a lot easier. But they do wrapper a great deal of open source in the base layer, and then all the other layers and all the other stuff that you put in there. So you've just taken your relatively simple microservice of a few hundred lines of code, and you've just added, I don't know, 1,500 dependencies around it, and perhaps a few binaries, perhaps the odd curl executable that shouldn't be there on a particular layer. These are problems, okay? So this is a real issue. And most of the stuff that you will see in the industry, wherever it is, whether it's free or paid for, is solving that problem, package managers. What about all the other stuff? Our research shows that on average, 20% of open source comes from outside the package manager, and up to 100% in some languages. C and C++ being the common example of the 100%, but it does vary, okay? And of course, I don't really care about that because I know about it. As in, I do care, but at least I know about it. In my mind, I'm more concerned about the stuff I don't know, okay? The stuff that, the malicious, the insertion and so on. Okay, so what are the risks? Believe it or not, I'm just setting the frame. We've got a lot more to go. Don't worry, I am watching the time. I'm not going to bore you completely to death. So what are the risks? Well, there's lots of stuff that needs to go on. So we've got the vulnerability workflow. We've got stuff like IP risk and compliance, which you know about. We've got information leakage, malware, and we've got misconfigurations and other stuff. So lots of things that can go wrong, again. And we can spend a few moments walking through what that looks like. So here's a cycle. I could put my code in using the package manager or any other technique, NPM, I can use an IDE. I can put the code into commit, into SCM. I can then build it with a build tool, Jenkins. Many others are available, commercial and free. Appium testing. I could then package it, perhaps using Artifactory to put the packages together, or there are, again, other binary repositories are available, and I can release it using AWS code pipeline or whatever I'm doing. Okay, so lots of stuff, hundreds and thousands and literally millions of combinations of stuff you can do. And then, of course, this is where all the holes are. I can have code that is bad. I can have vulnerable dependencies, log4j, and we'll talk about that in a minute. I can have malicious packages inserted into, in places which they shouldn't be, doing things that they shouldn't do. Information leakage. I can have misconfigurations. I can have malicious code, SolarWinds. We'll talk about that in a moment as well. I can obviously ship modified packages, which is a problem. That's essentially what happens with SolarWinds. And then obviously I can have vulnerabilities after the fact. Okay, so there's a lot going on here, a lot of moving parts. So let's try and break it down into a few pieces here, okay? And again, I don't have the time to go through everything here, so I'm going to go quite quickly if that's okay. If anyone wants to slow me down, then do. But essentially, let's look at the exploit workflow. So log4j. What was log4j? Well, many things actually, but one of them was a thing called JNDI, which stands for Java, some naming, something, I can't remember. I can never remember the four-letter acronyms, who can? But essentially, it was a way of enabling logs to go and look elsewhere to get extra data to put into the log, okay? But clearly, if you are clever, you can put something into the front of an application, like a web, a text field or something, and you can craft it so that it has a JNDI embedded inside it, which causes log4j to log it to the log and then go and get more data from somewhere else. Because this is a Java application, the cycle is that it goes somewhere else, gets a piece of Java code, which you install into the JVM, and you're now in control of that. And that's essentially what the remote code execution for log4j was that happened in December 2021. And we know that hundreds of millions of web applications were affected. We know that last year, at the end of the year, still 14% of production web applications were vulnerable to this, nearly 4 years later. And we also know that at peak, every hour, there were 10 million malicious attempts to break into websites using this specific vulnerability every hour, 10 million attempts, okay? So we have really no idea how much data and what happened there, but it was a massive issue, okay? And again, there's issues on how we found out about it and what we did about it, the fact that it's still there. These are all sorts of problems. And this is the crux of the problem. More software written by more people and AI and more vulnerabilities. That is the profile of vulnerabilities, by the way. I've estimated 2025, that's an approximation based on the June figures. It could be much higher than that, okay? Part of that problem is that the Linux kernel team have started creating CVEs for every issue because they think it's a bug that could affect everything. And so those have to be assessed as to whether they're real or not. And what we do know, again, is that the NVD failed in 2024. By the end of 2024, 50% of vulnerabilities reported in 2024 had not been assessed at all, okay? What we do know is that 44,000 are still in the backlog. So the NVD, if everyone knows what that is, I mean, CVE's public reporting workflow is not working. It's broken, okay? Why? Because the numbers have gone haywire. So the idea that the NVD is the source of truth is a real problem, okay? And we do have to look at that. So anyway, this is what it looks like when you see an NVD weighting analysis. I'm sure you're intimately aware of this because you've seen a lot of it probably, especially in 2024. Essentially, we have no score, we have no identification, we have a description, nothing else. We don't know what's affected, we don't know what the issue is, we don't know the severity, we don't know what to do about it. We don't even know it exists, to be honest. It's just a placeholder. And the question is, why is that happening? Now, Balazs showed us why that's happening, because issues are being reported in various places, and there aren't the people to process those issues. So the open source people are busy, they've got other things to do. The issues get escalated as issues. Perhaps they might get escalated as a CVE, not always. That's the point. That probably should have been a CVE, what Balazs reported, if you think about it, reported against that component. And then obviously, what happens when we get a CVE? Well, it goes into a list, but that list is restricted or reserved because you're not allowed to know about that CVE until it's fixed. So you have vulnerable code with a potential exploit in the wild, and you don't know about it because that's the workflow, because the people who write the code are allowed to fix it first. Okay, not a good idea. And then obviously, at some point later, or never, the NVD scores it, okay, and other people score it as well. And then what you have is you have these people called CNAs, CVE numbering authorities, who come in and do the score at various points. They may even be the creators of it. You can see CNA here, but they don't agree. They're all different. They all mark different affected components. But the whole point is that the exploit, that is the thing that we really worry about, could be anywhere. It could be never, or it could be immediate, or even a 0 day, you know, so that's the issue. So it's a real problem here, slow, inconsistent, intermittent, okay? So we just need to be aware that there's something wrong with the workflow. And another point is that it's the time to exploit vulnerabilities has gone from 63 days in 2019, is that, to probably 0 in 2025, probably seconds in 2025, I would say. I mean, I put 1.5 as the average. I don't have the data. We don't know. That's a guess, by the way. But you can see what's happened here. That's in days to exploit a vulnerability, okay? So we don't have a lot of time, but we have a lot of gap in knowing about it. So we need to do something about it. One other point to make is how much of the software that we could see is affected by this sort of thing. So again, we do a private vulnerability feed, and we assess that 3 out of the top 10 of the vulnerabilities that we reported across thousands of projects were not reported, not in the CVE list. So it is big, it is there, it's 30% of the top 10 and 47% of the total projects affected. So issues there, okay, it is definitely happening, okay? So we need to do something about this, okay? And I do have an answer. And then, again, probably we don't have time to go through all of this because we've got lots of stuff we can walk through. So come and talk to me afterwards, but the malicious package is the next one. So not just vulnerabilities in code that are, you know, people being nice and just forgetting it, getting it wrong. We've got things like hacking, hacked accounts. We've got North Korea creating hundreds of packages in NPM and Ruby gems and PyPy and all the other places. We've got GitHub, which was hacked with hundreds of thousands of repositories that were created by an API. We believe that that was a cover for actually doing a few manual ones that they couldn't notice. GitHub fixed it because they noticed the problem and they removed those 100, but that was the shadow, you know, it was the way of shading the possible problems that go on there. And we've got things like this called the brand jacker, okay, which essentially is an AWS object multi-part copy thing. So again, just for terminology, we're talking about typo squatting, which essentially is using a package very similar to something else in the right place. So just missing off an S off OpenSSL or something, I don't know. So that's called type squatting. We've got brand jacking, which essentially is the process of creating a identical named component in a different ecosystem. So NPM to something else, and people get confused, okay, and they start using that. And then the final one, of course, is dependency confusion, which essentially is using package names internally, which are the same as external packages, and sometimes the package manager gets confused, and that's deliberate, okay? So that's more of a thing that you can do rather than someone else. But there are these issues of vulnerable components and so on. And again, we talked about a little bit, the SolarWinds hack. Again, another major issue that we had in the industry. And for time, essentially what we're talking about is somebody got a phishing attempt to get some credentials to log into a network at SolarWinds. They then inserted malware, but the malware was not for that purpose. It was actually in the build process. And it sat there in the build pipeline looking for the word Orion, which is the software that they were trying to hack. And they then inserted a DLL called Teardrop or Raindrop, depending who you are. And then they distributed that to 18,000 corporations who installed it in the core of their network, including, as far as we know, every European government and all of the parts of the US government, okay? So we don't know what happened there. We will never know what happened. They were probably attacking one or two, and they've just got a lot more, do you know what I mean? But who knows what happened with that data. So yeah, quite a lot going on there, and that is a simple supply chain hack. All that happened was people trying to hop from one thing to another to do something. And so we need to start testing the tools that we're actually using. And then finally, a release compromise, which is the CodeCov hack. So that essentially was where, and again, I'll jump through it for the purpose of discussion, but essentially people modified something inside a container available from GitHub, and that actually then started sending malicious code from people who were developing, data, sending sensitive data from people who were developing and testing applications using CodeCov. Okay, another example of a supply chain hack. And again, we don't need to spend much time on that. Just some more data here that one of the major ways in, and we saw it, Balazs did it, I don't know, I can't see him, but he did exactly that, didn't he? That was exactly what we're talking about. It was a credential that was identified, extracted from the system and used to do something else. And we see here that in 2024, there were lots of credentials on the Google Cloud, essentially breaching the Google Cloud with credentials there, and 19% of them were essentially leaked secrets inside ChatGPT. People put code in, put Docker file, forgot that they need to parameterize, and then if you're clever, you can get it out again. So those sorts of things, okay? Now, one final thing, and again, I'm trying to not go too long over, not at all over here, is this issue of licensing, okay? So you probably know it, but all open source has licenses, and if it doesn't, you shouldn't use it, okay? Because there's a licensing issue there. So don't use code without licenses. There's only a tiny amount that don't. And most licenses, thank goodness, are permissive. This is the MIT license. It allows us to do almost anything, okay? The only thing you need to do is to tell people that you're using that piece of software and give them the license text. That's the only requirement, okay? You do also, depending on territory, have to comply with copyright as well, but that's a different discussion. We'll come to that in a minute. Clearly, you know it and you love it. Things like the GPL, version 3 here, the bits in red are restrictions on using open source in commercial software or services, okay? And that's the problem. So it's designed not to make money for corporations. So if you're trying to deliver a service and you incorrectly link or use a piece of GPL code, by the way, you can distribute it, but you can't link it. It's called close coupling, okay? So there is this whole issue. And again, I think I've already covered it, but there are lots of obligations. This is output some of our tools that tell you that the problem with the GPL is that you are required to disclose your source, and you do not, you have to give the right to copy, and you cannot sub-license. What does that mean? Your entire application is GPL. Every line of code is now GPL, just by using one component carelessly, or a few lines of code as your own custom code, or closely linked to your custom code. So just be aware that there is this issue with open source. Don't not use open source, just be aware that you need to be careful of the stuff you're closely coupling. Using a dependency in NPM, for example, is not close coupling, okay? Just to be clear, that's okay, but doing something else is, and so try to understand what the difference is there. I'll jump past that as well. I don't know if I've got time. I've got about 5 minutes, 10 minutes perhaps. So what's the issue? Well, if you don't do this properly, you can be sued. It's not going to happen, though. I mean, it happened last time some years ago. There's a few in the last decade. Very unlikely. The real issue, oh, by the way, the one that we all know is the Linksys, the Cisco Linksys, if you're familiar with that. So they copied GPL code into the core of their router, and they then had to open source the entire router range. And Cisco just bought Linksys, and they had to offset $5 billion for the acquisition because all of that became open source. And if you're familiar with OpenWRT, that's where that came from. Okay, so it was the code from the Linksys routers, which all had to be open source, and you can still download it to today. But the real issue is around IP, and also when you try to get money for your company. So for example, say you're a startup and you do something. This was a friend of mine who, when I started at Black Duck, said, I know Black Duck, we've been Black Ducked. And I said, that sounds terrible. What happened to you? And he said, essentially what we did was we wrote some code, an application, new application. Then someone said, have you checked it for open source? And we did, and we found a few things which we got rid of. But we had this one piece of code called LZO from OpenHumor. I think it's 120 lines of code. Couldn't get rid of it. Couldn't reprogram it. Too difficult. Too good. Didn't have the time. And so they then had to agree a commercial license with that company of $250,000 a year every year for perpetuity, which is a bit shocking, really, isn't it? For 120 lines of code, but it's either that or not release the software. So just be aware that's the sort of thing you're talking about, is do you own your software or do you have to buy a commercial license? All right, so the good news is there are some solutions. No such thing as perfect, but they're better than what we have currently. Okay, and again, I really, as you see, I haven't really done a commercial presentation. This is about problems and interest and so on. But clearly, I work for a company and we have some stuff which can do this, okay? So essentially it can scan every type of software in binary, source, config, anything, container, anywhere, and identify the origin of it, because we have a knowledge base which is 20 years old of every single piece of open source that exists or existed, hashed down to the every file level. So for example, for the Linux kernel, we have 8,500 versions of the Linux kernel stored, every file and every module, all hashed, and each one of those from 100 different origins. And that's one component out of 10 million, okay, in the knowledge base. So we've got it pretty well covered. That's why Black Duck is known as the SCA tool of choice for people who care, okay? And that's essentially what it does. And then the other thing is that we've not got it solved, but we're doing a lot of work to try to improve the vulnerability workflow, especially now using AI to enable us with that. So essentially, we're taking issue feeds from multiple places, including the reserve list of the CVE, including social media news groups and other places, including the issues that are not escalated, but also from our competitors like GitHub Security Advisory and so on, and creating things called BDSAs. And they sit alongside CVE, so you can see the BDSA is ahead of the CVE by 6 months or 5 days or whatever it may be, and it has the information. And each BDSA has all the information you need to solve it, including what is the description, what's the issue, how is it classified, how do you fix it, where's the code release, and how is it scored. And we rescore from scratch, okay, using experts and using AI. And we've been doing that since 2017 on every vulnerability. So it's a lot of work, it's millions of dollars. We have 70 people working on shifts to try to do this, and clearly we're using AI to help us with some of those fast-moving vulnerabilities as well. And it's because if you're delivering commercial software and you have all these responsibilities, you need to know within hours that problems are happening and that you need to do something. And you also need to know what to do about it and where it is in your portfolio. Good, so final point. There's been a lot of talk in the industry about shift left and shift right. Okay, so shift left, it means it's the developer's fault. Okay. Shift right means it's operations fault. Fix it in production. Okay. I heard a piece of data the other day. On average, it takes 6 seconds for all the data to be egressed from an application. So it's too late in production. Okay, runtime protection, probably too late. It's a nice idea, but probably too late. We really shouldn't be putting that code in production, okay? We should catch it earlier. And the shift left thing is essentially, as I say, making it the developer's fault. And we're talking about automation and DevSecOps, DevSecOps. What does that really mean? It means running things in pipeline, automation, okay? And that is great. And I'm not saying don't do it. I'm just saying you can't rely on it for everything, because it's mainly focused on packages in some package managers. It's mainly focused on simple workflows. There's much more to do with this. And what we say is that really it should be shift everywhere. Okay, so security, application security is the responsibility of everybody in a company, and especially the executives. And they should be enabling you, whatever you do, to solve the problems that you need to solve quickly and effectively and before you get to production, okay? And that doesn't mean just using open source tools and not paying any money for proper feeds of vulnerabilities, although clearly open source has its place and is absolutely critical for some things, but you have to pay for some stuff because you just can't do it yourself, okay? So that's the point, is the executives need to be responsible. Like they, you know, if we remember the agile supply chain and all that, it was all about the executives not taking away the money from each sprint. Do you remember that? All that stuff we had decades ago. And that's exactly the same thing. Treat it as a real issue, fund it properly and solve it, okay? And that's really it. So that is the end of my presentation. Thank you.
My first question is, Google recently published an blog where they say, you know, that agentic AI developer then was able to find a vulnerability, publish it, and then it also got a CV from it. Right? So what's your take on that particular thing?
What, that Google is, what, publishing vulnerabilities or creating vulnerabilities?
Yes. Publish was not just agentic AI that published Google.
Okay.
CV was published on the name of that agentic AI.
On the name of it. So it's a real CV against a non-AI piece of code. And it was created by AI,
Yeah.
the CVE. Yeah, exactly. We're doing exactly that. But as I say, it's not just that, because you need to know that you have the vulnerability or the code that's affected in your code. You can't just rely on a bunch of CVEs. It's about knowing what's in your software, scanning the binaries, scanning the executables, scanning the source code and the config, the containers, every file and every container. And SBOM is a good idea, but it doesn't solve that problem, because SBOM is a way of communicating between external agencies, or perhaps internal, but it really is just a way of communicating. It's a form of data. If the data isn't good in the first place, the SBOM is rubbish, okay? So that's the point, is that it's a good idea. And by the way, I think there are some workflows there to do that. And we're already doing it. So we're already working on that. And we have AI-generated BDSAs. The problem is that vulnerabilities can't be published until they are fixable. And that's the issue, because you are opening the entire planet. So you need a private feed of vulnerabilities anyway. Is that helpful?